Hello,
Okay.
everyone. It's 1 p.m. in Japan. Welcome to our webinar session. This is the third of the webinar series on intermediate waste treatment technologies. Today, we will focus on mechanical biological treatment. Before starting, please let me share with you some housekeeping announcement. This webinar is co-organized by those four organizations: the Japan Society of Material Cycles and Waste Management, National Institute for Environmental Studies Japan, United Nations Environment Program, International Environmental Technology Center, and CCET. One of the co-organizers, the Japan Society of Material Cycles and Waste Management, is going to organize an international conference called 3 Links, which stands for the 3-Year International Scientific Conference. 3 Links is going to be organized in March, and today's webinar is also a related event of 3 Links. The details of 3 Links will be shared at the end of this webinar. And we have received questions from the participants in advance. Thank you so much, those who shared your questions, comments. We have gone through all the questions, and the presenters here today will cover them in their presentations and discussions as much as possible. The time is so limited today, so we may not have enough time to answer additional questions. But if you have any, please put at the chat box at the bottom of the screen. Also, we would like to receive your feedback on this webinar. So please kindly fill out the online questionnaire after the webinar. The link will be sent to your email address at the end of this session. Your feedback is pretty much appreciated to consider our future events. This webinar is being recorded. The recording will be uploaded on the CCET website after the event. At the CCET website, you can also download all the CCET guidelines list. But today, this webinar is going to begin with the opening remark by the director of CCET, Mr. Onogawa. So please let me pass the floor to Mr. Onogawa.
Thank you. Thank you, Tatsuno-san. Dear speakers, participants, thank you very much for your participation and welcome to this webinar on mechanical biological treatment, which is a part of guideline series seminars on waste management of IGES CCET. Since its establishment in 2014, CCET has worked for waste management under 3 pillars of activities, which are development of waste management strategies at national and municipality level, development of reference materials on the proper waste management with a purpose to play as a knowledge hub on waste management for CCET, and the third, outreach activities, including the outputs developed through the aforementioned works. Today's webinar is one of such efforts of CCET in collaboration with our partners, which have been already introduced by my colleague, Ms. Tatsuno. Dear participants, a couple of days ago, just a couple of days ago, I was reading on a homepage of OECD on waste management subject and came across a very much interesting paragraph in it. It reads, more and more waste is being diverted from landfills and incinerators and fed back into the economy through recovery and recycling. Mechanical and biological treatment is increasingly used to facilitate recovery, enhance incineration efficiency, and reduce the amount being landfilled. This is a very much encouraging observation of OECD that MBT is being used more and more as an essential technology to enhance 3R activities with a final goal to promote efficient resource use. It also leads the share of municipal solid waste landfill in the OECD areas has decreased from 63% to 42% between 1995 and 2018, which means around 23 years of time, I think, with some countries no longer using landfills. For example, Switzerland, Germany, Finland, Sweden, and Belgium. These countries have stopped to use landfilling in their waste management. Yet, landfilling remains the main waste disposal method in several countries. For example, in the OECD America region, means USA and Canada. We can learn from these observations that landfilling is not the long-term directions of waste management anymore. And countries are shifting to better treatment technologies while utilizing the MBT technology more and more in the course of waste management. Also, it shows that MBT is not only for developing countries, but it is getting an interest of developed countries as well, with the understanding that MBT is a useful technology to promote resource efficiency. Dear participants, today, in addition to the introduction on mechanical biological treatment by Dr. Ishigaki, National Institute of Environmental Studies, Japan, we are learning the cases of real application of MBT on the ground in Thailand and India from Professor Chat of Thailand and Dr. Mazmudar of India. Further, Dr. Honda, UNEP ITC, will discuss the issue of technology applications on waste management with a focus on developing countries. I hope today's lecture and discussions on the subject MBT would be enjoyable and useful for the application in your countries. Thank you very much for your attention.
Today, Dr. Chert is going to moderate this webinar. So please start, Mr. Chert.
Sorry, I should have invited. Okay.
Welcome all the participants of this webinar. So today we're going to start with the presentation by the lead author of the guideline, CCET guideline on MBT. The title of the presentation is Mechanical Biological Treatment for Improving Municipal Solid Waste Management in Developing Countries. So the presentation will be made by Dr. Ishigaki from National Institute for Environmental Studies. So may I introduce Dr. Ishigaki briefly? He is now the senior researcher at the National Institute for Environmental Studies, Japan, and he obtained his PhD from Osaka University. He has been working extensively on solid waste management in Japan and also the other part of the Asia, especially like Southeast Asia and South Asia. So he's focused on the waste disposal and biochemical engineering and environmental microquality. So I think the floor is yours. Thank you, please.
Thank you, Dr. Cha, and good afternoon, everyone. Again, my name is Tomonori Ishigaki from National Institute for Environmental Studies in Japan. Today, I'm going to touch on the CCET guideline series and try to introduce the mechanical biological treatment, MBT, for improving the municipal solid waste management in developing countries. The principle and the definition on the MBT. This is the MBT is the pre-treatment method before landfilling that is developed in European countries, and it aims to reduce the amount of the waste, especially the organic waste, to be disposed of. And the strong benefit of MBT is it can be applied for mixed solid waste without the source separation or systematic segregations. And MBT can produce the solid fuel, so-called refuse-derived fuel or solid recovered fuel, that is called as RDF or SRF, as a part of the separated fraction of the high calorific value from the waste. So what is the MBT in theory? The MBT is the combination of the biological process and the mechanical process. And the order of these two processes is not fixed, but it's more like a flexible. For example, one city will start the process from the mechanical process and then move to the biological process. But the other practice, the system start from the biological process but move to mechanical process. Or some city can adapt the mechanical, biological, and mechanical. It is very flexible systems to be adapt the technology. And each process includes several kinds of the technology for treating the waste. For biological treatment, it generally includes the several technologies such as the aerobic decomposition or anaerobic digestions or bio-drying technology. And this biological process aims the partial degradation of organics in the waste and also aiming the drying of waste. And for mechanical treatment, it includes several technologies such as crushing technology or shredding technology and sorting separation technologies for the waste treatment. And it aims the separation of the solid fraction of fuel to be, and but there are so many technology regarding with the mechanical and physical process, so that appropriate technology it should be selected by the physical properties, physical characteristics of the waste in the local or regional situation. And the output of the MBT system, the major point is that they can produce the solid fuel, so-called RDF or SRF. And if the system adapted the anaerobic digestion, we can also obtain the biogas that is also utilized in the energy recovery systems. And MBT process also can recover the certain recyclables or valuable materials through the separation process. And other remaining part should be generally sent to the waste landfill. But once we adapt the more separation or seeding processes, we can also obtain some fine fractions, so-called compost-like organics or compost-like outputs, so-called CLO. that has the potential use in the construction industry. And so that there are several reasons or motivation to implement the mechanical biological treatment for municipal solid, for municipal solid waste management in developing countries. The big motivation should be that is the practical and reasonable sanitary pre-treatment technology of the waste. And it can contribute to avoid the direct disposal of the waste. And of course, it can not only to reduce the amount of the waste, it can improve the quality of the waste to be landfill. So not only to save the landfill capacity, it can also contribute to reduce the environmental pollution regarding with the landfill management. And not only for the waste issue, but also I can emphasize that it enhances the renewable energy production by recovering the solid fuels, which must be coupled with some energy recovery systems in private industry or domestic municipal waste to energy systems as well. I'd like to explain more detail about the benefits and advantages of MBT. In terms of the waste aspect, yes, I repeatedly said that it can reduce the volume and amount of the waste to be disposed of. And since it can improve the quality of the debris, so we can also reduce the risk of the infection or toxic hazards compared to direct dumping or direct landfilling. It is also it also contributes to achieve the Sustainable Development Goal, the goal number 11, sustainable cities, and also contribute to goal 12, responsible consumption and production. And for technological issue, the MBT is well known about the high affinity or high feasibility of the utilization of the local existing technology. And in general, it doesn't require the advanced technology or high-end machines. And this is very important part to implement in the urban area in developing countries in terms of the reasonable and sustainable operation. And since we can adjust or arrange the technology that suit for the regional properties, regional characteristics of the waste, so that, for example, in Asia Pacific region, we are always struggling to manage the wet waste or moist waste, so that we can control that kind of the waste by several combination of the local existing technologies. And for resource aspect, this is also a very important issue that that MBT can produce the solid fuel or biogas for the generation of power or heat. And this is also contributing to the SDG goal 7, affordable and the clean energies, and as well as the goal 12. And not only for the fuel issue, but the MBT also can recover the certain recyclable materials. And also there is a potential use of the compost-like organics, CLO, as a materials for backfilling or a material for temporary cover in construction industries. And for environment aspect, yes, this is a very appropriate waste treatment technology, so that of course we can contribute several environmental improvement of the environmental qualities. But the most important thing is that this is also contributing to reduce the greenhouse gas emission in overall process of waste management. And as I already mentioned, it also reduce the landfill-related environmental pollution by reducing the amount of waste and also by improving the quality of the debris. Last part, but very important part about for the financial or economic aspect. Yes, I want to emphasize that the operation of MBT is a lower energy intensive and low cost operation compared to the other waste pretreatment technologies. Of course, that is also combined with the application of the local technologies. And to get, in terms of the financial balance, as the sales profit of the solid fuel is is a kind of the essential, especially MBT operators. And not only of the sales profit of the solid fuel, using the solid fuel, I mean that the SRF or RDF is also very strong benefit or motivation for the fuel users, such as an industrial furnace or industrial boiler, or municipal RDF plant, or RDF power plant, or district heating services. And they should have a certain benefit or motivation to implement or introduce the MBT in the society. Yes, not only the fuel, the valuable resources, recyclable material could be a possible source of the profit of the systems. And it can also contribute to improve the financial balance as well. So the MBT might be attractive for several parties in the region, such as the local authority that want to enhance the regional resource efficiency. Or MBT might be attractive for local authorities that is looking for cost-effective pretreatment method before landfill. Or local municipalities that must maximize the landfill capacity, or I should say that must save the landfill capacity. And this is also attractive for the central government that wants to expand the renewable energy or that is shifting to a circular economy. And for waste to resource industry, or I should say waste recycling or waste management industry that wants to expand the economic incentives from waste management and waste recycling. There is a big attractiveness for that kind of the private industry as well. And the industrial user, this is also attractive for the company that wants to save fuel cost or to expand the possible use of the recycled materials in their business. These are the common driving force to implement the MBT, but not only for or by one party, but it is also important to share the common understanding or agreement on this kind of attractiveness by the stakeholders, all stakeholders in regional societies. So if we talk about the benefit or recommendation in the regional society, MBT is recommended for the region that is under urbanization or under development and need to develop the integrated waste management more without enough financial affordance. Because MBT is a very reasonable and sustainable way. And MBT is also highly recommended for the region that possesses the industrial background for solid fuel utilizations, such as the concentration of the cement industries or the lignite power plant or waste to energy plant, and also heat demand at paper manufacturer, wood industry, or printing industry. That is the very strong source for utilizing the SRF or RDF. So it means that the MBT doesn't come, the implementation or introduction of MBT doesn't come the technology only, but it is highly depend on the situation of the society, regional society or local society, such as the size of the city or industrial background or industrial concentration with the reliable logistics of the waste and the logistics of the recovered resources as well. So there are several key elements for planning, construction, operation, and of MBT, which should be considered in the planning stage. I mean, at the before implementation. I'd like to talk the detailed information about the precondition for achieving the sustainable MBT. And for social conditions, the very important thing is that the securing use of the SRF or RDF. And this is kind of the mandatory key criteria to consider about the MBT implementation. And together with that, securing the feedstock for solid fuel production is also essential, very important. It means I should say that the securing the stable waste collection is important in the society. And for social need, yes, the strong social need to introduce or understand to implement the MBT is the important. That's the kind of the advised key criteria. And this is very close, but the public awareness is also mandatory required, especially to incorporate the waste, source separation of waste to avoid the contamination of the hazardous waste or infectious waste for safe operation of the MBT, and also to keep the quality, or I should say price of the SRF or RDF. And for institutional aspect, yes, to keep or to create the schemes to promote the utilization of the RDF or SRF in place. And securing site for MBT operation is also strongly advised. And for governance capability, the cost consciousness is very important. Of course, most of the private companies should have that, but even the municipality or local government should have the certain cost consciousness to save the waste management cost. And MBT must be positioned in upper level plans, such as in the master plans for waste management or urban development plans and so on. And for financial aspect, is that securing the revenue by sales of the RDF or SRF should be very important. And for technological issue, the basic data on local waste and locally available technology should be considered at first. And the information on these technology or data must be collected in advance, as well as the localized or local technology, available local technology should be developed and collected in advance. And for all technological part, I prepared some slides, but I think the following presenter gives more technological issues. So I just quickly introduce my presentation. But in general, mechanical process include the waste processing and waste separation. And there are lots of the local waste preparation or waste processing technology, such as crushing, shredding, splitting, and so on. And so that is, of course, one important thing is that it is adjusted to the local quality or local properties of the waste. And also the operation should be selected in terms of the reasonable and sustainable operations. And waste separation processes. This is also sometimes we struggle to select the appropriate technology due to the difficult separate efficiency. So not only the separation technology, that is also combined with other drying technique. Of course, it includes some mechanical drying or solar drying, and we can also recommend to implement the bio drying. And in biological process, so that is one reason that we strongly recommend the bio drying in the Asia and Pacific regions to obtain or to improve the quality of the waste to be to achieve the well separation. And the topics on a good practice is not my it should not be included in my presentation. That is totally well presented in the following presenter. So I'd like to close my presentation. Thank you very much, and I'd like to return my microphone to Miwa-san. Thank you very much.
Thank you very much, Dr. Ishigaki, for your presentation related to the subject of MBT. Okay, so I think now we're going to proceed to the short presentations. So we could see some of the example of the MBT application in other part of the other countries. So may I start with my presentation on the waste stabilization in the different MBT system. And that this is a case study in Thailand. So just briefly about me, I'm Chat Jemchaisi from the Department of Environmental Engineering, Kasetsart University, Thailand. So we have been working on some study related to the MBT system application in Thailand. So I'm going to briefly introduce the example of the MBT application in Thailand. So first, we have the three different type of MBT system that has been implemented in quite a biggest scale in Thailand. The first one is we call it windrow type, and this is some adaptation from the system that has been employed for waste stabilization of the municipal solid waste, but later on is slightly shift toward the production of the RDF. In this windrow, okay, MBT, so we start with the waste stabilization, okay, and then after that we do the physical separation of the waste component with high caloric value. So after that, the recover of the waste can be used as the refuse derived fuel and mostly used in the cement plant. I'm going to also introduce quite similar system, but in the quite the depth of the biostabilization is quite shallow. In that case, we call thin layer MBT, and quite the same concept that we try to stabilize the waste and recover all the plastic waste to be used in the as an MBT recovery. Another example I'm going to explain is about the bunker system. This is much a shorter processing time target, really to reduce the moisture of the waste, and after that we can use the dry waste as an RDF in the cement industry. And you can see all those applications linked to the use of the RDF in the cement industry. So mainly for energy recovery. These are the location of the three MBT system I'm going to talk about. They are located in different parts of the country, but mainly not very far from the area where the cement industry is located. So they are located close to the third system on the bunker system. So I'm going to show you the process of the first one. It's about windrow system. You can see from this diagram, we collect the waste from source and then it's brought to the transfer station of the municipality. And after that, the waste is brought to the site where the MBT system is located. The first part consists of the biological process. Now, actually, there is some debagging activities and homogenization of waste just before this biological process. But in biological process, we try to pile up waste into the like a windrow pile, and probably the height is about 4 meters, maximum height is about 4 meters. So it's quite like a windrow composting approach, but the main is to stabilize the waste. After that, after a long period of stabilization, the waste is recovered and then we can do physical separation. So the waste is going through the series of separation device, mainly to try to recover the plastic waste as a high caloric value so that we can use it to recover energy in the cement company. During the separation, you get some leaching, and then that consists of like soil-like material and some compost and some other part, some material are sent to the landfill, back to the landfill. So you can see this like a photo of this windrow system. You can see that this is a location. I would like to note that this MBT process was primarily developed for waste stabilization using the European approach, try to stabilize the waste so that we can have minimum carbon going to the landfill. But later on, it was converted to RDF production facilities. Okay, so you can see the picture of this windrow pipe, and then some equipment they use for the separation of the to recover the waste for to be used in RDF. We study some waste characteristic, and I think this is typical for many countries, developing countries. So our waste consists mainly of biodegradable waste like food waste, about half of it, and then we have also substantial percentage of plastic, which is this is the main target for this RDF recovery. So about 1/4 of the waste composition is plastic, and through the stabilization in the windrow system, after the stabilization, we're going to have like more than half of these component as the plastic waste, and actually the biodegradable waste will be biodegraded and then it's end up having like a soil-like material. Okay, so mainly this is a component that's remain after the biostabilization. Okay, now I'm focused on the waste stabilization in the windrow composting, and it's like a usually windrow pile, and then we pile up the waste from one place to another next to the each month we proceed to the stabilization this of waste, and then what we conducted during the study is we measure the gas emission, and that will be to be the indicator of waste stabilization. Unfortunately, because we use quite a large windrow pile, so there is a substantial methane produced during the degradation, so anaerobic function occur, and this pile is just on the with no roof, so probably during the very high rainfall period, the anaerobic condition develop in this pile. So we're going to have like this is a heat map of the gas emission, and there is some of the hotspot of the methane production inside this waste stabilization plant. Okay, and also we monitor the carbon dioxide and this go along with this methane emission. So actually, the waste stabilization inside this windrow pipe follow the same pattern as the landfill, and then you can see you can apply the same model that we use in the landfill, like first order decay model, to explain what happened in the waste stabilization in this windrow pipe. And you can see we have the gas rising period followed by the reduction due to the stabilization of organic waste. So we have found that the biodegradation of waste in the windrow pipe is just on between the aerobic composting process and the anaerobic landfill. So it's understandable that we have part of the waste in a very large windrow pipe to be under anaerobic condition, and part on the surface is aerobic condition. So it's like a mix between the aerobic and anaerobic condition. We have found that during this long period of more than 1 year, there are substantial degradation of the organic waste. More than about 35% of the organic matter is being degraded. So really, it's like a stabilization of organic waste. So this is what we found in this example. I'm going to talk about another system, similar system, but this is another municipality where they apply thin layer. So quite the same concept as windrow, but in this case, the height of the waste layer is a little bit shallow, less than 1 meter. And then again, we try to stabilize the waste, and then after that, we do just physical separation and recover the material as RDF. And you can see this is some photo of these facilities. And in the system, we have the waste coming in, and then it's spread over into the shallow windrow pipe, and then that is stabilized naturally. After that, we go to the physical separation, like through also like different type of the separation, and then try to recover the residue, right, the plastic waste to be used as RDF. We also end up having like compost or some other minor component. The pattern is more or less similar in terms of stabilization, but because we have the layer, so probably the waste stabilization took place much faster than the windrow pipe. So in that case, we found it's much lower in the gas emission, and the degradation rate is slightly faster because of the more aerobic condition developed in this windrow. Then we have another system for bunker. This is quite different from the previous two, because we try to put the waste into the bunker after some training preparation, and the waste stay there quite short time. This is only 6 days. During the stabilization, we provide some mixer, mainly just to develop some aerobic condition, and then to use the heat to remove the moisture. So actually, these target not lateral stabilization, but rather on the bio drying of the municipal solid waste within very short time. That's why it results in a very low emission of the gas. So we just try to remove the moisture so that we recover the waste as it is, if possible with higher caloric value because of lower moisture content. Okay. So I think that's briefly explain our experience with the waste stabilization in Thailand. So next one, I would like to request Dr. Masunda to give his presentation on the opportunities and challenges for MBT technology and policy decision on the ground in case of India. I will introduce briefly Dr. Masunda. Dr. Masunda is an international waste management expert, and then he has been working in the waste management for more than 35 years. Now he's honorary chairman of International Academy of Environmental Sanitation and Public Health, New Delhi, has a lot of extensive experience also as a consultant to like international firm like Asian Development Bank and also Institute for Global Environmental Sustainability. Okay, so I think Dr. Masunda, may I request you to give your presentation, please.
Yeah. So can my presentation be uploaded? IGES team. Uh, can someone load my presentation or should I do it myself? Yes. Thank you. So good morning, everyone. It's a great pleasure to be in this webinar in this August company of scholars and professionals. So I'll be talking about opportunities and challenges for MBT technologies and policy decisions on the ground in India. So I'll be talking basically about the Indian situation. Next, please. Yeah, yes. So you see, India is a large country with a large population, and the quantum of waste generation is huge, as you can see the figures. And but fortunately, the per capita generation is not that high. And as per our constitution, the waste management is a state subject. So it's not a central government subject, but a state subject. But in spite of a number of steps from the central government as well as many state governments, the status of waste management needs a lot of improvement in most of the municipalities. Next, please. Now, in the context of this webinar, I'll be discussing about the application of MBT in India. And you see, there has been a trend to move from centralized to decentralized processing and disposal facilities. As you can see from the policy changes of the government and the tenders which are being floated by the ULBs. ULB meaning the urban local body. And the most important driver of MBT, which my learned colleagues have already discussed, you see, the most important thing, particularly for India, is saving land for waste disposal. Because as you saw, the total generation of waste is huge. So saving of land is very important. Particularly if we can save land from dumping or even sanitary landfill, then it would be a great achievement. The next important issue is coping with the segregation at source. Now, what happens is every municipality, more or less, has been trying to introduce segregation at source, but with different ranges of success. Now, suppose I am designing a system. As a professional, I have to take the figures. Now, suppose the segregation percentage is, source segregation is 30%, or it is 50% or 80%. But when I design a system, it has to be either with a system where there is complete segregation at source, or the segregation has to be at the plant. In between is a difficult thing. So therefore, MBT would be there till this kind of concerns are there. So that's the second most important importance of MBT. And the third, and this also is very important, is the environmental factors, which have already been discussed by our August friends. So greenhouse gas, vectors and diseases, air and water pollution, aesthetic issues, and so on. Next, please. Now, here I'll give you an example of a particular city in India. See, what happens in India is the government, since 2014, they are carrying out a cleanliness survey, which in India it is called Swachh Sarvekshan. Now, this particular city called Indore city, where the 3R conference was held, this is a 5 times topper for cleanliness survey by the government of India from 2016 to 2020. So therefore, it would be interesting to see what they are doing and why not the other cities are doing as well. So this is a shining example of best practice. This city has 2.5 million population that generates a little over 1000 tons per day of municipal solid waste, in which the wet waste is 52, 58%, dry waste is almost 42%, and household hazardous waste and sanitary waste is 0.5%. See, in our rules, the waste has been divided into three categories as of now: wet waste, dry waste, and household hazardous waste. Along with, and the sanitary waste is usually put in the dry waste. Now, since 2016, Indore Municipal Corporation has been able to rapidly implement segregation at source and has achieved 100%. Now, this is a big control. If you have segregated waste, then it is easier to put your systems to further process it or treat it or dispose it. But this is one of the most important points. Now, the clue to success appears to be in meticulous doorstep collection. So, the door to door collection has been achieved in a meticulous manner. So, the segregated waste are put in tippers having three compartments, two in the main collection container and a drum with hinged cover tucked at the backside. The next photo would show. Next, please. Yes. So here you can see in the main body, there are two sets for the wet waste and the dry waste. And at the back, the small drum, which is there, this is for household hazardous waste. This has a lid. Next, please. Now, they have established 8 numbers of garbage transfer stations. They have different types: ramp based, then portable compactor based, semi portable compactor based, and so on. Then the bulk generators, like the marriage halls, the hotels, they have to install their own system for wet waste. Now, this has been put in many cities. And the households, they have been encouraged for home composting. With this kind of efforts, the Indore city has been able to reduce almost 100 ton per day of wet waste from the central processing facility. So much of carriage cost, so much of emission, air emission for the carriage can be saved like this. Now, biodegradable waste-based 3 biogas plants have been set up, and the product, which is compressed biogas, this is being used for public transport. Now, this is also supposed to be a great achievement. And then they have a centralized dry waste processing facility where they segregate it and sell the items. And the centralized domestic hazardous waste treatment facility. Here, it's with the biomedical waste treatment facility, and here they incinerate the material. Next, please. Now we come to the policy and regulatory issues in India. What drives? Because the government policy and the regulations and rules, they are one of the main drivers of a waste management system in a country. Now, we would all know that in an urban area, different types of waste are generated, but their management is interrelated. You can take any example. Therefore, the government of India notified 6 numbers of rules in 2016: solid waste management, construction and demolition waste management, biomedical waste management, plastic waste management, e-waste or electronic waste management, hazardous and other waste. Here, of course, the management and transboundary movement rules are there. So these rules can take care of the total gamut of waste management or waste generated in an urban area. Next, please. Now, apart from the above rules, another one called the Batteries Management and Handling Rules, amended in 2010, was also notified. And one very important thing, we have been talking in this webinar a lot about composting. Now, since a long time, if we look at the bottom of this thing, formulation of, uh, no, we'll come to that next. See, the quality of organic manure produced from municipal solid waste had been a difficult issue. And therefore, good market was not available, because if the user doesn't find that the quality is good, why should they purchase it? So therefore, FCO, which is Fertilizer Control Order, was finally notified in the year 2009 for standard of organic manure, and FCO 2013 for PROM. PROM means phosphate rich organic manure. Now these rules are very strict, and these are applicable this is when this compost is sold for application for food crops. Therefore, it's very important that application of these rules are meticulously followed. Now, a number of state governments have notified certain guidelines and regulations. For example, tire retreading, co-processing in cement, power, steel. We will come to this co-processing again. And formulation of Andhra Pradesh integrated municipal solid waste management strategy. Next, please. Now, here, the guidelines from the government of India. So the government didn't stop by making rules only. For assisting the implementation of the rules, the government of India has published elaborate guidelines from time to time. Some of them are Municipal Solid Waste Management Manual. This has 3 parts and runs to 1,000 pages. The Ministry of Urban Development had published it in the year 2016. Actually, the committee which prepared this, I was chairman of that committee. Now, guidelines of uses of refuse-derived fuel in various industries, Ministry of Housing and Urban Affairs, 2018. This also, I was chairing this committee as well. Here, we tried to divide the refuse-derived fuel or RDF into 3 grades. Grade 1, grade 2, grade 3, and the segregated uh, combustible fraction, SCF. The cement, we had a lot of discussion while this was being done with the cement industry. We also tried to rope in steel industry and the thermal power industry. But only the cement industry, actually, they responded. So we had a lot of discussion with the waste management industry and the cement industry. And they actually agreed for grade 1 and grade 2 to purchase or pay for grade 1, grade 2. But they said that for grade 3, they won't pay. And for the other one, that is the segregated combustible fraction, the party or the company which gives this material to them, they have to pay the cement industry, because they are going to further dispose it. This still is an issue, and this is still going on. We hope that in near future there will be a good rapport between the waste management industry and the cement industry. Then the report of the Interministerial Task Force on Integrated Plant Nutrient Management, which was published in 2005. Now, here we found out that quality of the manure is very, very important. So the FCO 2009 and FCO 2013, actually, the driver was this report. Then there was a report from the Planning Commission about waste to energy. That was a pretty thick report in which they talked about this issue. Next, please. Now, here I will briefly discuss about the plant and machinery used for MBT. See, I'm speaking here from my own experience. After retiring from government in the year 2005, I spent 11 years with a waste management company, a big waste management company where we actually did from designing, planning, construction to actual operation, maintenance, uh, marketing, everything. Now here, sorting. Electrically operated sorting belts, usually manned by 4 to 8 persons who just stand on each side and who are fairly skilled at their job with keen eyes and very deft hands, very expert hands. Those guys are very good at their job. Now, segregation is done mostly by trommels. Earlier, I mean, long back, about 20 to 25 years back, vibro screens were also popular, but later on, the industry shifted more towards trommels. Now, you have already discussed a lot about trommels, so I'm not going to discuss about this. So, what are the compost plants doing? Actual experience. For large composting plants, say 300 to 500 ton per day waste intake using collected mixed waste, not segregated waste, but mixed waste. Four trommels are used. The first one is a pore size 80 to 100 millimeter. Then the next is 35 and 16. They are in tandem. So first 80 to 100, the organic wet waste is separated and then it is put on windrows. After about 3 weeks, it is taken up and put through 35 and 16 pore size. But please remember that depending on the weather, every week that windrow has to be turned. My predecessor speaker was discussing a lot about methane generation, nitrous oxide generation, and carbon dioxide generation. So we found that if on an average, if the material is turned, completely turned once in a week, then the composting is better and you see the unwanted methane generation is much less. So after this 35 and 16 pore size, after that 3 weeks of stabilization, and thereafter finally 4 pore size. After 4 pore size, the material goes through a permanent magnet and a what you call a gravity separator or a destoner, so that all the inert materials are removed. And with this, it is possible to achieve the FCO 2009. That is what was my experience. But I'd like to tell you here that with mixed waste, starting with mixed waste, if you want to achieve the 2000 FCO 2009, then the yield of compost is roughly about 10% only. Next, please. Yeah, so magnet we have already discussed. Eddy current is not popular in India because most of the non-ferrous items, because they are more expensive, they are taken out by the informal sector long before the materials reach a processing facility. Now, shredders are a big issue. Shredders, both primary and secondary, especially used for RDF making. And in the RDF plant, of course, it has been discussed already, so I'm not going to repeat it. It's a combination of shredding, drying, and gravity separation so that the inert materials are removed and the combustible fraction only remains as RDF. So normally the class 1 RDF or the grade 1 RDF, the cement plants are ready to pay for it, even for grade 2. Now, what is a challenging factor here? It's about the shredders. So long, good shredders are not available indigenously. Biodrying is not popular in India so far. Of course, biodrying in the sense open drying is there, but then If you talk about a properly designed biodrying, it's not popular here. Next, please. Yes. Now there have been some endeavors, some effort for making a difference. Now, a number of organizations and companies, including startup companies, are trying to make a difference by taking different perspectives at the waste management industry. Now, the National Physical Laboratory is a very famous national laboratory in Delhi. They have developed a technology for preparing inert and strong boards from plastic waste, which can be used for light and temporary structures. I had seen them a number of times and they're really good. Now, another startup company, TrashCon, has fabricated an automated equipment to segregate mixed waste, which is claimed to be very useful during the pandemic, right? Because then you don't have to touch the waste. This was a big concern. Now, one of their equipment can make boards from different dry waste, including multi-layer covers. They call it wow boards. Now, one facility for segregation has been set up at the Dhapa in Kolkata, but it is to be commissioned yet. It has been set up, but it is to be commissioned. And another has been commissioned in Bangalore for segregation. In Dhapa, they have segregation as well as the board from the mixed plastic waste and the Tetra packs, multi-layer plastics, and so on. Next, please. Yes, now we come to the market for the products from waste processing. This is, I think, a very interesting and very, very challenging issue. Now let's first talk about the high organic carbon fraction, either compost or stabilized sludge from a biogas digester. Now, what are the issues? The issue is, which we already discussed, FCO 2009, you get an yield of 10% only. Bad quality manure doesn't sell, and it is illegal to sell bad quality manure, which is not uh, compliant with this FCO 2009. And major crops for them, if you target the major crops, then you need warehousing of the compost for almost 6 months. So there would be some 2 or 3 major crops. So you have to put your uh, material or compost for some time. So you need warehousing, which is expensive. I'm talking about all this from my own experience. Now, if we talk about renewable fuel like biogas, cleaned compressed biogas, now this is coming up fast, but so far there is no standard pricing mechanism. This is actually again a big difficulty. Whatever is doing, in many places it has been done, it is mostly on a pilot basis. We are yet to get onto a proper commercial platform where there is a pricing mechanism, there is a quality mechanism, and things move. Now, clean recyclables, to get money from selling recyclable material is also difficult, because if it is not segregated at source, they are soiled with food particles, soiled with mud, and so on. So clean recyclables is again, getting clean recyclables which fetch good price is again a big challenge. Now, how calorific fractions such as RDF, quality and price uncertainty, as we have already discussed. Sale of carbon credits. Now, at one point of time when I was handling all this, around the year 2006 to 2009, we were very gung-ho about the carbon credits and the certified emission reductions, CER. And good price was there, but that price has crashed already. So there is almost no hope. Next, please. Financial implication. Can municipal solid waste management be financially self-sufficient with MBT? Now, as we have already discussed, as per the Constitution of India, urban waste management is mandated for the urban local bodies or the municipal bodies through the state government. But a very important amendment act was passed in 92. That was the 74th Amendment Act of the Constitution, which devolved significant powers to the urban local bodies, including financial powers. Now, we all know that waste management cannot be financially self-sufficient on a standalone basis. You can sell some products, you can sell some recyclables, but they would be like bonus points. Unless you have some gate fee or something, it's not going to really be financially self-sufficient. It has to be funded from taxes and duties on the principle of polluters pay. That is very important. Now, in places where segregation at source has not been established, MBT can provide a lot of advantage, as mentioned in the third slide. We have already discussed this. Next, please. Yeah. So thank you very much. And the message that I have given to you is also about the MBT, that the MBT can be a very useful tool in the hands of the waste manager or those who plan waste management. But it has to be flexible, it has to be as per the ground, and it has to be derived after interactive discussion. Then only it can be successful. So thank you very much. It's a great pleasure.
Thank you very much, Dr. Masunda. And then maybe we will move to the next presentation on the technology adaptation for environmentally sound management of waste in developing country by Mr. Junichi Honda. So I think briefly explain, Dr. Honda is from United Nations Environment Program, and he has been working at Ministry of Environment, Japan as well. He obtained his doctoral degree from Shizuoka University. Okay, Dr. Honda, the floor is yours.
Yes, thank you, Chair. So how should we change ourselves to combat the global environment crisis? As waste management experts, what is our response to shift linear type of waste management system to circular type? We, the United Nations Environment Programs, nowadays rethink about what we should do to combat the global challenges on waste management, in particular under the COVID-19 pandemic. Our main question is why a country can implement environmentally sound management of waste, but another country cannot do that. In other simple words, this may be a never-ending discussion on one fundamental question, continued for the last 200 years, on what is different between developed and developing countries in terms of economy growth. So what should we do? This question is consolidated into also a fundamental question to combat the waste management issues. To answer these fundamental questions, we need to equally develop 4 pillars: policy, technology, social system, and people's awareness. Those 4 pillars are common successful stories among high-income countries nowadays. Mechanical biological treatment provides sort of answer to waste management issues to be solved on those 4 pillars. So I will be briefly discussing on rules of mechanical biological treatment for circular economy, and also discussing on future perspective of mechanical biological treatment based on those 4 pillars. So let's first discuss rules of mechanical biological treatment within the context of circular economy. At global level, we follow the definition of the environmentally sound management of waste under the Basel Convention. It says we need to segregate waste at source of waste generation as much as possible. Based on the international recognition and waste management practices, we tend to understand that we need to segregate recyclable waste as much as possible at the source of waste generation. And also we need to use waste management technologies to further recover recyclable waste at facilities. There are some common trends of waste management practices at different income level. For example, when a country develops their economy more than 2,000 to 3,000 US dollars as gross national income per capita, they tend to start introducing separate collections. This means that countries with such income level can choose waste management infrastructures with mechanical biological treatment, advanced separation collection, and or combination of them. When we look at our big challenge on circular economy as one of important factors towards carbon neutralization, what is important of waste management is in circularity. We need to use recycled materials as much as possible and to minimize extraction of resources from the earth. The key point is how to segregate waste at source of generation. Mechanical biological treatment helps countries which do not have the advanced environmental sound management of waste to promote recycling of waste because separation collection at waste generation is not common. However, they need long-term strategy, at least more than 10 to 20 years, of waste management towards circular economy, contributing to decarbonization of our societies. So policy, technology, and system help people to work for circular economy, but we are missing another pillar as we discussed at the beginning of my presentations. It is people's awareness. We need to avoid their awareness that they do not need to segregate of waste because they rely on mechanical biological treatment. Segregation of waste at source of waste generations educates people to develop their mind and capacity towards circularity and sustainability of our societies. We need to look at a big picture on circular economy and carbon neutralization while implementing environmentally sound management of waste at practical level. Then let me discuss the future perspective of mechanical biological treatment. So in order to consider about the future of mechanical biological treatment, I have two sets of figures to you. 22% in 2020 and 24% in 2050. So one more time, the 22% in 2020 and 24% in 2050. So what do you imagine with these figures? So in 2020, we generated about 50 billion tons of waste in total. Of 50 billion tons of waste, we only recycled about 22%. In 2050, we would generate about 64 billion tons of waste in total. Of 64 billion tons, we would only recycle about 24% even after 30 years from now, based on one simple scenario on population and economy growth. Even after 30 years, recycling ratio would only increase by 2%. Where do we see our tangible target on carbon neutralization and circular economy in this real situation? There is a huge gap of real waste management situations between the countries which can set target on carbon neutralizations with circular economy and the other countries which cannot do that. Many of high-income countries and the major countries can set such target, or I may have to say that those countries should set such target. However, majority of other countries are far behind to set such target by 2050. In real world, about 90% of municipal solid waste generated in low-income countries goes to open dumping sites, and about 70% of municipal solid waste generated in lower middle-income countries also goes to open dumping sites, and majority of those waste is treated by open burning. These practices would mostly like continue for next 30 years, unfortunately. Ideally, segregation of waste at source of generations is preferable. However, mechanical biological treatment continues playing important roles on waste management in low and lower middle income countries for coming years. As we have been discussing today, mechanical biological treatment is one of the environmentally sound technologies of waste and increases recycling of waste when all conditions are optimized. Low-income countries need to develop environmentally sound management of waste within their national context and their needs. One of options is absolutely mechanical biological treatment. Environmental sound management of waste should be built on 4 necessary pillars, so policy, technology, social system, and people's awareness. If a country introduces and implements mechanical biological treatment for waste, they also need to see a big picture how they can also shift their society to carbon neutralization with circular economy that global community aims at. So finally, let me repeat my 2 questions. How should we change ourselves to combat the global environment crisis? As waste management experts, what is our responsibility to shift linear type of waste management system to circular type? It is obvious that mechanical biological treatment is one of environmentally sound technologies of waste, in particular for low and lower middle income countries. We need to advance mechanical biological treatment as one piece of an integrated waste management towards circularity. However, only advancing and implementing environmental sound management of waste does not help us to shift our society to circular economy. We need to equally develop 4 building blocks: policy, technologies, social system, and people's awareness. So with that, let me finish my short presentation. Thank you. Over to you, Chad.
Thank you very much, Dr. Honda. Actually, now we should proceed to the panel discussion, but due to the very limited time, I would like to first try to summarize the key message we have in this session. So let me share you the key points that we have. Yes. From the information from the resource persons, we have seen that MBT's reasonable waste treatment methods to reduce environmental pollution, which low cost and energy consumption. MBT is also promising, and the enhancement of renewable energy and greenhouse gas reduction when it's coupled with the social and industrial conditions. Regional yield balance is a key factor for successful implementation of MBT. Okay. As one of the options of environmentally sound management of waste, mechanical biological treatment has role to push national and local governments, in particularly low-income countries, to shift them towards circular economy. MBT can be effective tool for appropriate waste management, provided it is designed in a flexible and modular manner as per the ground situation. And lastly, the selection of appropriate system depending on the waste characteristics and local conditions. And it's very well known that maybe the type of waste which can be covered or treated in the MBT system may also vary from country to country. So that's will be some of the key message that we can draw from this session. Actually, we have received many questions, and I think what we see from the question come focus more on the practical issue of the MBT and also the financial aspect of the MBT system, and also the public-private partnership scheme, if possible, to implement the MBT technologies. So probably I would like to maybe give the floor to the speaker just to provide a very brief view of what they would like to if there is any information to share on those like financial aspect, practical issue, or the how to operate sustainable MBT in the developing countries. Maybe I ask Dr. Chiki to give some information or view on this.
I'm sorry, I couldn't catch well, but do you call me?
Yes, maybe may I ask the speaker to give a very brief message, if you have some message to give to the audience, because I think probably we gather all the question from the participants, and then
Okay.
there's no time to give all the response to the questions. Okay, maybe some brief message you would like to give to the audience. Yes, please.
Thank you very much. And I could see that some question about the practical or implementation or feasibility of the MBT. And yes, if we talk about the feasibility study, we sometimes try to arrange the best condition for feasible implementation of the MBT at first or at the stage of the feasibility study. But in fact, the waste quality or even the amount of the waste should be fluctuate, as well as the separation or the production technology for solid fuel should be also fluctuate. It means that the quality is not stable. So not only try to show the best quality or the best always don't show the best quality of the technology, but we should set the certain criteria for the available or acceptable level of the operation of the technology to adapting the changing the waste quality, and also that the SRF user should also know about that things. And this is a very important point. And this is of course that is have a several good advantage, a benefit of implementing MBT, but it is also certain limitation because we are this is still the waste treatment technology. This is a very simple key message since the time is limited. So thank you very much.
Thank you very much. May I ask Dr. Masumda to may you have some key message to give to the audience?
Yes, I had sent it in writing also. It's a very small message. You see, waste management industry, particularly in India, it's not easy. I have gone through it for 11 years and I know. Although the government is trying to help, but it's not easy so far. Now, the message that I'll like to send to the participant is that the MBT can be a very important tool in the hands of the waste manager or waste planner who actually does the overall conceptualizing, planning, designing, everything. I mean, not only the technical design, but also the financial design, the social issues, everything. So it has to be flexible, and it should always be planned in an interactive manner, because we all generate waste. So each one of a citizen is a stakeholder in the waste management industry, directly or indirectly. So all these things should be in a interactive manner, and one should try to develop modular models so that you don't have any difficulty in implementation. Thank you.
Okay. Thank you very much for your message. Dr. Wanda, can I ask you to maybe give some key message to the audience, please?
Yeah, just a simple word. Let me give the waste management is not just for waste, because waste management is important for circularity that we have to develop in coming 3 decades. And the mechanical biological treatment plays important role and to support us to achieve such our ambitious goal and target. Over. Thank you.
Okay, thank you very much. I'm sorry that we have very limited time for our discussion. I think there are many interesting questions raised during to this webinar, and I think the organizer will try their best, try to raise points to those points which can be done later. I think we come close to the end of this webinar, and maybe I would like to pass the floor to Ms. Hasuno. He would like to give some information to the audience, to the participants. Yes, please.
Thank you so much, all the presenters. Your presentation was pretty much informative. If you don't have any additional comments, please allow me to introduce 2 other virtual events on waste management, which complement our webinar. CCET is an affiliate of UN Habitat's program called Waste-Wise Cities. They are also organizing a similar webinar series called Waste Technology Deep Dives. It covers e-waste, anaerobic digestion, black soldier fly larvae composting, material recovery facilities, and sanitary landfill. If you are interested in, please join their webinar as well. And also 3 links, which is scheduled on 11th and from 15th to 19th in March. 3 links is going to be organized by the Japan Society of Material Cycle and Waste Management. This year, due to the COVID-19 pandemic, the conference is going to be held online. Global academics, policymakers, and business representatives, especially those from the Asia-Pacific region, will come together for interdisciplinary discussion on waste management. In the special session of the conference, the topics will cover analytical methods of plastic waste, organic waste, and food waste management, disaster waste management, and waste management during and after COVID-19. MBT also will be covered in the session on March 17th. And the general session will cover a wider range of topics in waste management and material cycle. This is a unique opportunity to learn current and future waste management. So please visit the 3 Links website and get the detailed information to join the event. Thank you so much for your kind attention. This is all for the webinar. Thank you so much.